Well, 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 Thorpe Park. What's going on with you now? Let's take a look.
Now get ready. Here we go.
Ladies and gentlemen, welcome to the Ryan Ride Mechanic channel. How the heck are you doing today? If this is your first time here, make sure you like, subscribe, see more content like this. I do these sort of videos all the time. People send me the most interesting stuff, and I love working with it, honestly. It's a great thing. So today's video comes to me from an email. Actually, it's a two-part video. A viewer sent me this. It says, interesting video, thought you might want to see it. Colossus went down around 2 p.m. and the engineers seen in the attached video at 4:30. The ride never reopened and it looks like they are hammering the track back together. I would love if you had any detail on what you think they're doing. Let's take a look at this. Okay. All right, they're working on a track joint. All right. Let's see what they're doing. They got a rusty bolt and another rusty bolt. Okay. Okay. All right, so ladies and gentlemen, this is a track joint. Haha. Yeah. Alright, so typical track joint where two pieces of track come together. They're using two rails or two bolts, one on top, one on bottom, and the same thing on the other side. One on top, one on bottom. Let's see, who built Colossus? Okay, yeah, that's what I thought. Colossus was built by Intamin. This looks like an Intamin track joint. Basically, and they did a cool job. They put safety hardware in there to lock all the assemblies together. That's cool. So what's happened is that over time, this bolt has broken. Basically, the bolt on the bottom has broken. I'll play the video again here. Let's see if I stop it. Alright, so let's look at this real quick here. Sorry, let me move this playhead. So if you look right here, see how you've got this nut and then a locking washer. They're actually, it's like a jam washer, a jam nut essentially. They're tightened up against there. So he's actually holding this in his hands right here. So what's happened is that the head on the other side, the head has snapped and come off. So the bolt has sheared. It's now been taken apart. So what they're using right now is they're using this bolt right here to try to hammer this one out. Because while the track assembly is put together, all that stuff is under tension. It's under tension multiple ways. It's under tension in compression this way, like the bolt is under tension this way, but then the track is also misaligned in different axes. It's kind of all over the place. So that's typically why if you're mechanical, when you put something together, you don't put like an assembly together and it says, oh, it takes 8 bolts around that. You don't put bolt number 1 in and tighten it, and then number 2 and tighten it, then number 3 and tighten it. Because by the time you get back around to number 8, the assembly's probably off by that point, and you can't get bolt number 8 in there. So anytime you put something together, it's kind of one of those universal things for most mechanics and stuff. You always just start the hardware and everywhere you go. You start the hardware and maybe run it down and then you creep up on that. Now, a lot of people think a bolting pattern. It's like, yeah, for things that are like flanges and stuff like that, there's a bolting pattern. But just in general, you want to make sure you start the hardware everywhere. Well, track joints are no different. So what happens with a track joint is that you look in there and you say, okay, when the two pieces of track come together, when it's being built, there's mismatch. The track isn't quite straight. It's a little bit off one way or another. And then it's also off, if you look at it this way, it's kind of off like this too. And then if you look at it from the side, it's kind of off like this too. So every single axis is kind of off just ever so slightly. So before that section is bolted down to its column that it's sitting on top of, they kind of gently place 1 or 2 bolts in there and just kind of get the nut on the other side just to kind of keep it pinned in that space. Then they get the other piece of track and put it over there. They get all 4 track bolts in, and then they move on to the next segment. And then when they get that other one, they get all 4 bolts in that next segment, they go back to the first one and start to tighten that first one down. And then all the flange bolts start to get tightened down, and then the track bolts get tightened down. And for people who assemble track, there is a very specific process to doing this. A lot of times, like B&M in particular, they don't just put the bolts through on their rails. They actually use a tapered, it looks like a dual tapered cone, and they're alignment bolts, essentially. They put them in and they hammer those things in so it perfectly aligns the 2 bores on all 4 sides, because B&M does the same thing. They use 2 bolts on each side to hold the track. So it aligns that entire assembly, and then the very last thing they do is they go through and they drive those 2 alignment dowels out one at a time. They drive the first one out and they put a bolt in and tighten it. Not all the way, but they just snug it up. And then they put the second one through and they put a bolt in there as well. And then they start to really tighten those things down, probably 80% of their value. And they go to the other side and then drive those out. So what happens is when you break a bolt in the assembly, like what's going on here, is that that assembly slightly shifts just a little tiny bit, enough to where that the one bolt comes out, and they had to drive it out because it is pinned in there. Because as they did that, the 2 holes suddenly just went off just by enough to hold the bolt in there. So they had to drive the first bolt out. And now what they have the problem is that that second bolt that has to go in doesn't want to go in. So if we watch this just a little bit. Listen to the sound of him hitting it. Listen to the sound. The actual, the ting, the feedback to it. Did you hear what that sounded like? I'll play it again. Listen to the pitch change. Listen to the pitch change. Hear it get hollow right there? Right there. So what that is that's what we call, from the roller coaster maintenance industry, we call that sucks right there. It sucks a lot. Because it was driving that first bolt out with that other one. Now, that orange one, is this going to be the final bolt that holds the track together? Maybe not. Sometimes mechanics just use a pin that's been kind of ground down just as a, like, okay, we just need to drive something out. And they use it as a long punch, essentially. Nothing wrong with that. But there's a good chance that orange bolt won't be the final one, but it could be. I don't know. So what happens is that sound as him hammering was nice, and it was basically just thud, 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 because each time he was hitting that other bolt was coming out just a little bit, probably 10 millimeters at a time, just do, 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 do. And then when that other bolt finally came loose, it came loose because it passed that separation in the track. Once it passed that separation in the track, that other bolt just came right out. Now the first bolt was being hammered towards that separation, and it goes doot, doot, and then it started going clank, clank, clank. That was the sound of metal on metal. Basically, in the bore, those 2 holes are no longer aligned with each other. So that was the sound of that new bolt hitting the interior of this side right here. So this bolt was going through, and then it finally hit this other side, and then it started going clank, clank, clank. That means it's about to get rough. You have 2 options as a mechanic in this position. The first one is to get a bigger hammer. The bigger hammer theory wins a lot of the time in the maintenance industry. So you get a bigger hammer and just drive that mother effer into that hole. And then when it comes out on the other side, you have to make an inspection and determine if the threads were damaged, how many of the threads were damaged, and can the bolt still be used. I've done this myself. If you hammer it in there and it folds over the lip on the top of the first thread, then you could just take a file and fix that first thread and then run the nut back down. And the rest of the threads are fine. It just needed to get through that initial little bit of misalignment. And I know a lot of people right now, it's like, you're a for just hammering that thing in there. It's like, hey, I do what I need to do to make sure people can ride the rides, right? All right, so that's the first thing. So you get in there and you hammer that thing in. Then you make sure it's not, because if that bolt is flattened all the way down and you're like damaged all the threads down that bolt, you can't use that bolt. It's got to be replaced. I'm sure even if you had a manufacturer standing here looking at it going like you're hammering a bolt in there, I'm sure even they'd be like, nope, you can't do that. Option number 2, and this is the one that is pretty much never ever taken, is you have to do what's called relaxing the track joint. I've talked about this in other videos before. You have to go in there, you have to go that top bolt, and you have to loosen that bolt. And then you have to go to the other side, and you have to loosen those 2 bolts. And then you have to go to the flange that the thing is connected to and loosen those bolts so everything can move again. Once that happens, you can now grab the rails and bend and twist them into whatever thing you need to, and you need big stuff to do this. Come-alongs, pulleys, things like that. You have to basically twist the track into a new shape to put that bolt back in there with no tension whatsoever. Now, that's rarely ever done because that is like a 3-day project when you're talking with a ride that's already been commissioned and it's up and running. Nobody does that. And you say like, well, you shouldn't be hammering bolts in there. It's like, you know what? Go to a site where they're building one of these rides and watch them when they put that track together. Listen, they're hammering bolts in there too. That's what they do. That's what everyone does. That's what you need to do for these things. The misalignment is so slight, the precision is so tight that you end up hammering things in there a lot. They might have to go back and design something to go in there and fix the misalignment. So if the bolt, that doesn't look too big. That looks probably like an 18 millimeter shank bolt. So if the bolt's 18 millimeters, the bore is 18 millimeters. So it's like, okay, go back to the shop, get a piece of long rod that you need. It's probably 200 millimeters long. And then I'm going to take the nose of it and machine it into a nice cone. And then take the other side and I'm going to machine that into kind of like a cone, but it's more like a cup at that point, just a slight curve like that. And then what I'm going to do is I'm going to take that guy, push it into that bore where it starts to hit. I'm going to use a punch and then start to drive that in to where that cone starts to align those 2 bores. And then once that goes in about 100 millimeters, I'm now going to use my new track bolt and put that behind it and continue to drive that all the way through, hoping that when that cup finally passes that joint and the 2 try to go like that again, that bolt's already in the way. And then it's like, okay, then we can continue on with that. I've been, and what did he say? That said the ride was down? Yeah, said the ride never reopened that day. So my guess, it wasn't just a hammer it in there type scenario. They had to go back and probably fabricate something to get that in there. Maybe come back with some hydraulic jacks or something like that. The problem you run into with opening the top bolt is that you're going to have to replace it. And then so it's the same thing. It's the same exact problem on the other side now. It's like, well, if you open that up to replace it, then the thing really moves. One thing manufacturers tell you is that when you're working with joints, especially like old Vacomas and stuff where the rails did the 50-50 overlap like that and you had 2 bolts going through it, they will tell you never ever take apart the track joint all the way. You could take one bolt out, you could take the other bolt out, but don't take them both out at the same time, because if you do and the thing springs on you like a piece of spring steel, you can get seriously hurt, like extremely hurt, because if you had a hammer on there and that thing suddenly unloaded, it could literally project the hammer through your head, like super dangerous. So never open a track joint without relaxing it first. So if you go to relax it, then you have to do everything, and most every manufacturer says once you back the tension off one of those track bolts, you have to replace the bolt. It's a lot of work, so you have to be very careful about putting that stuff back together. Now, the crappy part about those, which a lot of parks don't do, I've been guilty of it myself, is when you bang a track bolt like that and you snap the thing apart, you go in, you're like, okay, lower track bolt, you get the new one in, tighten it back down, and you're like, good. Mechanically, engineering wise, the top bolt in that assembly is, you can't verify that it wasn't overstressed. And I've seen them to where you break the bottom one, you replace it, and then a little bit later you break the top one because it was overstressed when the bottom one broke. So realistically, to do it correctly, you have to replace the bottom one, and before the bottom one is torqued, you have to replace the top one and then torque them both down at the same time. Pain in the butt. Those people out there, those guys working on that stuff, that's really some hard work to do. So, and I hate it. I mean, I'm grateful for the video. So cool that video got sent to me, because that's true work that you don't normally get to see. So I'm completely grateful for that. At the same time, I hated doing stuff like that with the park open because of people doing like videotaping and stuff like that. It's like, it just looks bad. That's all it is. It looks bad. There's nothing wrong. It's like, why did it break in the first place? There could be 1,000 reasons why. We don't go into that really. It's just like, they're making the repair. They're gonna do it. Don't worry about it. But yeah, I mean, if I had to replace a track bolt in a high visual area like that, a lot of times I would just be like, hey, I would beg management. It's like, can we please just leave it down and see if we could do it tonight after the park closes? Because I don't want everybody watching us replacing a track bolt. Someone will make a video on YouTube about it. Sorry. But this is regular maintenance stuff. This is what happens to rides. Not all the time, but this does happen. This is actually a rare thing to break a track bolt. And it is one of those things that probably will break again in that location, because once you start breaking track bolts in that location, there probably will continue to break track bolts in that location. And it's very slight mismatch in manufacturing tolerances versus installation tolerances. It's very slight stuff, but it's a gremlin, and they're hard to get out of there. It might take 5-10 years to figure out what the actual problem is to maybe stop it, but it's in between that time, so you might have to replace a track bolt per year. Okay, doable. And the head of that other bolt probably just fell straight down. They don't really go too far. All right, I told you this is a 2-part video. Let's get on to part number 2. All right, back in the same email, and it says, Hyperia also never opened again today and was awful yesterday. Hyperia, what did we talk about? Like, what's going on? Don't tell me this is your lift, because if this is your lift, we're going to have some words after this video, okay? Engineers seen removing drive tires from the bottom lift hill, and rumor amongst the staff is that the drive tires were pulling too much electricity and e-stopping the ride, so the trains kept getting stuck at the bottom of the lift hill. I attached this video too. Thank you. I appreciate that. That's awesome. Let's take a look at this video. All right, Hyperia, let's see what you got. Yeah, booster wheels at the base. Yep, there we go.
Oh, you're kidding.
Oh, man, that sucks. Okay, so we can pretty much tell on this where it tripped. So if we watch it come in again, the high pitch is the motor running, and then it shuts off right about...
Oh, you're kidding.
Right there. So what happens is that it's going over those motors, and where the train was, if you look at it, it didn't trip until right here. So if you look at where the boosters are, there's the last 2 boosters right there. So as the train drives forward, it's about right there. So it's on the last booster. So the train is right on the very last booster drive when it trips. Now, this is So what happens is the last booster drive is going into an overload scenario, which pretty much means that the motor's worn out already. It's going through, and it's like the amperage is increasing more and more and more until it eventually gets up there and trips a circuit breaker. And when the circuit breaker trips, it says, I've got a problem in the motor control center, and it shuts everything off. It essentially sends the ride into an e-stop condition. And so it shuts the lift off, it shuts everything in that area down, which is why the vehicle stops on the lift. At this point, the chain dog should be hooked up to the lift, so it shouldn't be a problem. The lift should just be taking it away. Now, why is the motor tripping? Don't know. Probably just worn out. Let's see if we can listen to everything again.
Oh, you're kidding.
It sounds like the lift motor picked up the load.
That's what she said.
The other thing would be to say if the lift motor didn't pick the load up and that one motor was trying to push the entire train up that lift hill. Possibility. But honestly, with this stuff, the precision's very tight on the amperage ratings that go into those motors. So it's watching it. It says it should have like a 1.7 amp pull, and it's set to trip at 1.9 amps. So if that amperage just gets up a little bit too high, it trips that breaker, and then as soon as that breaker trips, it shuts the whole thing down. And then you have this, which is where it stopped there. So the solution was they went out and basically had to remove that booster wheel. As long as the ride can function that way, okay, remove the booster wheel. No problem, get it up there. If it was like it couldn't function without that booster wheel because it couldn't get the train high enough up the lift hill in order for the chain dog to grab onto the chain, then you would, if you don't have another motor, which the park may or may not, don't know, but if you didn't have another motor, you would have to go back and grab one of the other motors and then do the famous rob Peter to pay Paul and take the motor out of position number, not the very first one coming in, but the second one up, and then you move that to the front, and you have to swap the bad motor so the ride sees the feedback from the motor. Robbing Peter to pay Paul doesn't work that great in those scenarios, but it's probably, it could be something minor. It could be even something like the brake is dragging on the motor if the wheels have brakes on them. It could be the motor brake is dragging just a little bit, causing the amperage to go too high. But since it happened with the load as it's going up the lift hill, I'm willing to bet that it's a simple overcurrent, and it's probably just a bad motor. Now, I know a lot of people are going to be like, how is it a bad motor just 2 years into the ride's life? It's like, yeah, that one's odd, but not unheard of. I've had bad motors on brand new stuff. Brand new stuff. It was a bad motor. Especially coming after the off season. Did water get inside of it? Moisture is the pecker head, which is where all the wires come into the side of the motor. Is that sealed up and tight? Are they eventually going to pull that apart and find out there's condensation all over the inside, which means the coils are shorting internally? All sorts of stuff like that. So luckily, it's not a chain liner issue, I guess, what it was before, where the train was stopping on the lift up there. Now this is looks like a circuit breaker tripping to the motor issue. All right, that's going to do it for this video. Subscribe, like, do all that stuff. It does help me out. If you want to email me, go ahead. It's RyanTheRideMechanic@yahoo.com. And as always, stay off the air gates. Bye.